Okay guys, welcome back. So in the last video I talked to you about the principal theory of calorimetry. So in this video, as I told in the last video, I'll be talking about a practical example in which calorimetry is used, so that you will get a practical example and a good experiment, and also a further understanding of how calorimetry is important in heat and overall physics. Alright. So I'll take a question like this. A question says like this: a 1 kilogram block of metal at 300 degrees of Celsius is added to 100 grams of water in a 50 gram calorimeter. Now calorimeter is an instrument in which we are doing the experiment. So calorimeters are the basics of calorimetry. So calorimeter is think it's some vessel, right? Some aluminium or something vessel like that. Calorimeter. So the calorimeter specific heat is 0.2 kilograms per Celsius, right? So that's the specific heat capacity. If the final temperature is 70 degrees of Celsius, find the specific heat of the metal, right? Find the specific heat of the metal. So we'll draw a simple setup to illustrate this and then put the theories we have learned so far in calorimetry. Alright, so the question is saying like this: a 1 kilogram block of metal at 300 degrees of Celsius is added to the system. Alright, so simply we'll draw that. A 1 kilogram, so its mass is m equals 1 kilogram. Mass is added initially at 300 degrees. So this is 300 degrees at initially. Is added to 100 grams of water in a 50 gram calorimeter. Alright. So this is the calorimeter, right? So this is the calorimeter. And this is water. So the mass of water is given as 100 grams, so that is 0.1 kilograms. And the mass of the calorimeter is given as 50 grams, so that is 0.05 kilograms. 0.05 kilograms. And we have been given that the system composing of water and the calorimeter is initially we have not been given, right? If the final temperature is 70, right? Alright, we'll take the initial temperature to be 30 degrees, right? 30 degrees of Celsius. Okay, 30 degrees of Celsius. And we have been given that when we are adding like this, the final temperature of the system, so the final temperature will be like this. Final temperature of the system, so this is water, this is the calorimeter, and this is the block. This is the block I am talking about. So the final temperature of the system is 70 degrees of Celsius. So we have to find the specific heat capacity of the calorimeter. So the specific heat capacity of water is normally 4200 joules, or 4.2 kilojoules. So these are the stuff only given in the question. So here m equals 0.1 m water, C is equal to this one. So m is equal to here 0.04. What is the value of C? So that's the question, right? What is the value of C? So what we can prove is that the heat lost by this object is equal to the heat gain by heat lost by this object is equal to the heat gain by the water calorimeter composition, right? Alright. So we can say, I'll take this system as A. Take this system as A and this system as B. Right, what I can say is that the final energy from the calorimetry equation, we can say the final energies of these two systems are equal. So we can say QA is equal to QB. So this is at the final moment, not the initial. These are the final movement, not initially. So the heat loss by, so its mass is 1 kilogram. So we can say MC M. So what is being asked is sorry, this specific capacity, this is given as 0.2, right? This is given as 0.2 kilocalorie joule kilograms per Celsius. Kilograms per Celsius. So we have been asked the value of this one. So what we can say, we have to find the value of C. What we can say is that the mass of metal, I will take mm times C times delta theta, the difference in temperatures, is equal to this system QB. QB is composed of both the calorimeter and water, but the calorimeter specific heat capacity is not equal to that of water, so we can take the whole mass, then multiply it by the specific heat capacity and then multiply it by the temperature difference. We have to take it individually. So I can say mass of water times the specific heat capacity of water Cl times its temperature difference plus mass of the calorimeter times the specific heat capacity of the calorimeter times the temperature difference. So this is the equation that we can write for this sum, right? So we have to substitute and find the value of C. So that's simple. So the mass of the block of metal is 1 kilograms. So always write the units in this kind of equations or substitutions, because you want to find it in SI units. So 1 kilograms. Specific heat capacity is the one we have to find, and its temperature difference. Initially it is at the temperature of 300 degrees of Celsius. Finally the system is at 70 degrees of Celsius. So the system is composed of both the metal, water, the metal and the quantity of water and the calorimeter. So the temperature of all the constituents, the temperature of the calorimeter, the temperature of water and temperature of the metal, all those things are finally 70 degrees. So the final temperature is 70 degrees, initial temperature is 300 degrees, so the temperature difference is equal to 230 degrees of Celsius. Right? 230 degrees of Celsius is equal to the mass of water. Mass of water is 0.1 kilograms. 1 kilograms. Put a bracket here. Right? I'll put a bracket so as to separate these two. And its specific heat capacity is 4.2 kilojoules. 4.2. I'll write 4,200. Right? 4,200 joule kilogram per joules per kilograms per Celsius, right? Joules per kilogram per Celsius. Right? Joules per kilogram per Celsius times its temperature difference. Temperature difference is now the initial temperature is 30 degrees and the final temperature is 70 degrees, so there is a temperature gain of 40 degrees. So the temperature difference is now 40. Right? 40 plus the mass of the calorimeter. The mass of the calorimeter is 0.05 kilograms. 0.05 kilograms times its specific heat capacity has been given as 0.2 kilocalories, right? 0.2 kilocalories. So what it actually happens is that we have to convert this, right? Kilocalories. So 0.2, right? 0.2 times 1000 calories per kilogram. I'll take this one as joules, right? I'll take it as joules. It's easy, right? It's easy because we don't have to convert the units. I'll take it as joules, right? I'll take it as kilojoules per kilogram per Celsius, right? So this 0.2 kilojoules means 0.2 times 1000 joules, because 1 kilojoule is equal to 1000 joules. So this is 0.2 times 1000 joules per kilogram per Celsius times the temperature difference. So the temperature difference is the same for that of the water, so that will be 40. So yeah, kilogram to kilogram cancel. This is Celsius, right? This is Celsius and this is Celsius. This Celsius to this Celsius to this Celsius cancel. Units are cancelling, right? So you will get the answer in joule kilogram per Celsius, right? Alright. So 1 times 230 is 230. So here is 230C. This is just an equation now. This is just an equation. It's very easy. 230C is equal to 0.1 times 4200 times 40. 0.1 times 4200 is 420. 420 times 40, so that will be 4200 times 4. So that will be 8, 8, so that will be 16,800. Plus this part 0.05 times 0.2 times 1000 times 40. So 0.2 times 0.5 times 1000. So that will be 5 times 10 to the power minus 2, 2 times 10 to the power minus 1. So that is 10 to the power 10 times 10 to the power minus 3. That multiplied by 1000. So 1000 to 10 to the power minus 3 cancel. So this will be 10. 10 times 40 is 400. Normally the total heat given by the calorimeter is a fraction of the total heat given by the mass of water, because of the not because of the mass of the calorimeter, but because of the drastic drop in the specific heat capacity in the calorimeter compared to that of water. So that's comparable, right? So this is 230C is equal to 17,200. So C is equal to 17,200 by 230. So that will be equal to 1720 divided by 23. So that will be 7 divided by 2, 46. So C will be approximately 74. C will be approximately 74. C will be approximately 74 joule kilogram per Celsius. So sorry about that if you made the calculation taking this as kilocalories. I changed it to kilojoules. So I invite you to, if you don't mind, you calculate it again with and find whether you are correct, right? So C is approximately 74 joules per kilogram per Celsius. So that's the specific heat capacity of this metal. So that is been asked. So that's a simple problem in calorimetry. So see you next time with the next topic, with a new topic on heat energy and thermodynamics. See you then.